Hello, welcome on my YouTube channel. Today we are going to discuss about the universe, different things. That is the facts most of the people wanted to know about them. For example, origin of universe, space and atmosphere, solar system, galaxies, sun and all like that things. For example, what is the things includes in the formation of suns? Most of the people wanted to know the life of sun, life of the earth, how much further remains their lives. Today we are going to in details. Thank you very much for watching me this video. Please help me like this video. This time we are going to start in detail video. The envelope of gas and the dust particle that surrounds the various celestial bodies of the universe due to the force of gravity is called atmosphere. On other hand, space is a wide region that exists beyond the celestial bodies. When we look at the scheme of the thing across the scales, we come across a very striking similarity. On the lower side, if we consider an atom as the most basic unit of our universe, we will see that only a tiny fraction of it is occupied by a matter, subatomic particle like proton, neutron and electron, and the rest are the void space. Similar is true on other side of the scale. It is the vast emptiness of the universe, which is the intersected with the various celestial entities like the stars, planets, satellites, and asteroids. These entities are arranged in the numerous local groups such as galaxies, kind of a mini universe, clusters, supercluster, and filament of galaxies. None of the above celestial units group are the statics, they are in continuous move and undergoing changes, whether small or big, by a very passing moment of the time. Further evidence suggests that the universe is expanding, that is, volume of the space inside it is increasing. Scientific community agree well to the fact that the same law of nature govern the entire cosmos. However, we witness a variety of phenomena across the space. Why it is so? Take for example atmosphere of our planet Earth, which also encourage to flourish various life forms are significantly different than it known as the nebulous like Mercury, Venus, Sun, Moon. The properties of the atmosphere such as thickness, density, chemical, all the composition on the different bodies of universe and whether the phenomena unfolding they are depending on many factors. These factors can be like the size and the mass of primordial matter from which an existing body has formed. Mechanism of evaluations, evolutionary phase, stage of formation, physical chemical reaction that are taking place, location inside the universe, galaxies, Earth and other planets, and distance from the neighboring celestial bodies. An an examination of the facts about the phenomena happening in the space and in the atmosphere of celestial bodies will help intimidate ourselves with our own universe and to dispel various myths. Scientists have theorized that at the beginning entire universe, the matter, it entered the mass energy and the space was confined with a very very tiny dot. Call it ancient primordial matter, as happen when a dying star become a black hole. In numerous compression with such a tiny dimensions due to the effects of the gravity might have caused a condition that Einstein equation termed as a singularity, a point where the laws of physics would simply break down. It is quite possible that all the matter was in the form of pure energy as compression of the massive mass of the universe. Please like the video and subscribe the channel for related videos in the future time. Magma is extremely hot liquid and semi-liquid rock located under the Earth's surface. Earth has layered structure that consists of the inner core, outer core, mantle and crust. Much of the planet mantle consists of magma. This magma can push through holes or cracks in the crust, causing a volcanic eruption. When the magma flows erupts onto the Earth's surface, it is called lava, like a solid rock. Magma is a mixture of minerals. It also contains small amount of dissolved gases such as water vapor, carbon dioxide and sulfur. The high temperature and the pressure under the Earth's crust keep magma in its fluid state. There are three basic types of magma: basaltic, andesitic, and the rhyolitic, each of which has a different mineral composition. All of the types magma have a significant percentage of silicon dioxide. First of all, basaltic magma is a high in iron, magnesium, calcium, but low in potassium, sodium. Its ranges of temperature 1000 to 1200 degrees centigrade. A star is born as a larger ball of very hot dense gas, not a solid. In the course of time, most stars develop their own planetary system, exception being the binary stars, whereas central star is surrounded and orbited by a number of planets, and some of the planets may again be orbited by one or many numerous of the moons. Atomic elements of the universe were hydrogen and helium inside the core of first generation star, where the temperature condition is like that of nuclear furnace. These lighter elements fuse together and give rise to heavier elements like the carbon, oxygen, nitrogen. The latter elements are essential requirement for formation of the various life forms can be seen on the Earth. Universe doesn't waste anything. Take the case of the star. When a star dies, it scatters most of its masses and element into the space, leading to formation of an entity known as nebula. A nebula can be assembling of the star dust, gas and dust of the single dying star, as well as subsequent colossal collection of them. In the course of the time, again one or many stars are born from this star dust. In fact, nebula are the most active star producing region within our galaxy. Our universe, as we observe today, continuously expanding, a fact which has been inferred from the Hubble Space Telescope data on color spectra, where the most known galaxies are found to be red-shifted, like the Andromeda galaxy, which is blue shifted. The Earth, like all other planets in the solar system, started out its life as a disk of the dust and gas orbiting the young sun. Earth grew to its final size through a one last major collision with another Mars-sized object. This last collision, also known as the moon-forming impact, was so large that, in addition to adding the lots of material to the Earth, there was enough energy to vaporize the sum of the rock and metal from both proto-Earth and impacting object. This vapor formed a disk around the Earth that eventually cooled and clumped together to become the moon. We know this thanks to rigorous studies of the meteorites and the rock sample, including at the University of Chicago in the 20th and 21st centuries. Understanding how the Earth and the Moon form is important for piecing together the history of the solar system and answering the question like how long planets take to form, what planets are made of, and what makes a planet suitable for life. This also guides planetary scientists in their search for other habit